Okay, so Unit 12, Lesson 3, this is Logs Day 3. We're starting off with some review here. And the goal for today is basically to just do more complicated log questions. But it always boils down to rewriting. How can you rewrite it unless you have the other side of the equal sign? And if this doesn't have an x in it, you say equals x. Really, that's the way I would start these. Because then when you rewrite them, you have to be able to go back and forth to both sides of the equation. All right, so this becomes log base 7 of the cube root of 7 squared, which if you're aware of fraction exponents, should be written as a fraction exponent. I want you to try to write that as a fraction exponent and then do a rewrite. This to the this equals that, and then hopefully you'll be able to know the answer, and it'll be a fraction. Then I'd like you to check with the person across from you. These two rows, check with the person straight across. These two rows, check with the person across, except two of you have to like just do right, you go right behind you. And then your two rows, person straight across, you guys just kind of diagonal, but okay, check and see if they got the same fraction. I'm going to pause for a second while you try that. Okay, I checked with my students, and yes, they had gotten 2/3 because it's log base 7 of 7 to the 2/3 equals x. And can you just say, since these two are the same, that's the answer? Yes, you can. But if you're not that fluent yet on those properties, that if the base and the argument are the same, that the answer is the exponent that's on the argument, you can say 7 to the x equals 7 to the 2/3. And that makes it really obvious that x equals 2/3. All right, good. Take a look at this one. This part right here, it's like it has a parenthesis around it, and it's to the 1/4 power. Do that kind, I call it get the clump alone problems. And be careful. Pause for a second while you try that. So let's see how you did on this one. It's definitely harder. 2x plus 1 to the 1/4 plus 7 equals 11. That's just a rewrite of the original problem with a fraction exponent instead. Then I always like to say get the clump alone, and this is our clump. And then that means to subtract 7 and then divide by 2. And 11 minus 7 is 4. So I'm just going to save myself a rewriting step, and then I'm going to divide by 2. And now that cancels that, and it's getting 2, or 4 makes, divided by 2 is 2. There we go, and this is getting a little messy, so I better rewrite it. X plus 1 to the 1/4 equals 2. Then I got to undo the 1/4 power, put it to the 4th power, and 2 to the 4th is 16. X plus 1 is 16. Now, does this one need absolute values? Nope. It's if we put it to a 4th root. We put it to the 4th. We didn't put it to the 4th root. If this had been like over a 6, for instance, or a 2 or anything even, if we'd have done that, we'd have needed an absolute value. But we did not do that. We put it to the 4th, not a 4th root. So no absolute value needed. I know it's tricky, but you got to get used to it. So hopefully it won't happen to you much in pre-calc. There we go. 15. Raise your hand if you had that one right. Now, if your life depended on it, could you check this? Yeah, you just have to take the 15, stick it back in, see if it works. Let's just do it quick. 15 plus 1 is 16. 4th root of 16 is doable. That's 2. And then 2 times the 2 makes 4, and then 4 plus the 7 makes 11, and I know it works. Now, should you check a problem like this, especially since it has a square root in it, you should check it. Because there's a chance that you're going to get an answer which you stick back in and doesn't really work. So if you didn't check it, you were running a little risky there. Okay, one more for review. This is just simply a rewrite problem. I would say equals x and then try to make the bases the same. Or if you're getting really skilled at this, you might be thinking, okay, I could rewrite this as a 4 to the something, but it's tricky. You could make that a 4 to the something, but it'd have to be a 4 to a fraction exponent, and it'd be like, whoa. So if it's too hard to do that, then totally just rewrite them. 4 to the x equals 36. And then now both of these bases can change. It'll be a lot easier. We've done base change like this many times, so I'll pause for a second while you give that one a shot. Okay, so we need the calculator for this one. And I didn't notice that when I assigned it to you. I was thinking we were just going to make the bases the same. But the problem is you can't make a base into without some really tricky gyrations. You can't make this 36 into a 4, and you'd need to basically guess and check on your calculator. So I think it would have been a much more doable problem if we made this into a 32, and then you could have done it with just in your head. But back to, here's what I asked you to do, and some kids did notice it say on the board with calc. So then of these two ways to do it, that way is way easier on the calculator. You could do it with either, but I would choose this one because this just is log 36 over log 4. Now if I'm typing that into my calculator, one common mistake people make is they go, and I understand this, you go log 36, and then they right away say divided by. But you've got to complete this log 36 and the parentheses, divided by log 4. Otherwise, what it's going to do is take 36 divided by 4 and then do the log of that. Anyway, so log 36 and the parentheses, divided by log 4. Log 4. And there we go, 2.584, blah, blah, blah. Any questions on that one? Yes, sir. All right, I bet you it's that thing I just talked about. So would you try typing in this? Log 36 end parentheses divide by log 4. And only on that very last one we don't have to have an end parentheses because it defaults to, kind of puts one in there for you in its head. Weird, your calculator won't do logs. Can you bring it up here? Let me take a look at that. I'll pause for a second while I've never seen that one before. I got to figure this out. So he's just using the wrong button. No big deal. All right, there is a couple different log buttons, and for right now I just want you using this one that's the simpler one to just log that log button, and you'll learn more about what the natural log is later, and other ways you could type in log. Okay, so anyway, let's talk about today's stuff. We're basically just going to have 3 different types of equations that have x's in them. You could hide the x in the equation as the base, or you could hide the x in the equation as the exponent, and this is the easiest kind because if you have a calculator you can just type it in. Or you could hide the x down in the argument. So there's just 3 spots where the x could be. All right, and we'll learn to solve each of these types of equations over the next few days. So what we're going to start with for today is if x is the base. It's really, honestly, if you know how to rewrite, these are easy. They really are. You just got to rewrite them. Look, the teacher's first step here on this one was to rewrite it and say x to the 3rd equals 8. You get that? That's just a rewrite. We've done that multiple times now, even today. And now we put it to the 1/3 power on both sides, and we be careful. Is this the kind where absolute values are needed? Nope, because it's an odd root. If this had been an even number, we would have needed absolute values. Okay, so then it's the cube root of 8, which is 2, and that's it. X equals 2. That's a typical question. So this is just do a rewrite. Don't freak out because there's a fraction in it. Just rewrite it. And it says no calc. Remember, part of your test has a calc and part of your test has no calc. So here's what you should have done on this one. You should have said x to the 3/2 equals 27. That's just a rewrite. And you got to get used to this circular back and forth thing with logs. And then I got to put it to the power of 2/3. Again, I keep asking just because it's going to come up. I did not use a even root, so I don't need absolute value. So then the final answer is just cube root of 27, which is 3. 3 squared, which is 9. X equals 9. Raise your hand if you had that one right. Okay, good. So this is going to be, I warned you that the last couple of days have been really especially hard. Today's easier, definitely. Now it's just this. Just remember to put it in parentheses when you do your rewrite. So this is x plus 4. Remember the parentheses. If there's ever more than one thing down there, or in the argument, you got to use parentheses around it. And then to the power of 3/2 equals, come back around, 8. Then put it to the 2/3. Did I just put it to an even root? No, I didn't. So I'm fine. Cancel, cancel, and cancel, cancel. X plus 4 equals 8 to the cube root of 8 is 2. 2 squared is 4. And then I subtract 4 from both sides. X equals 0. Okay, hold on. It's a minus. I said plus 4, and it's actually a minus 4 here. And that means this is a minus 4 here. And then that was going to, I was going to check it, just so you know. Really, I was about to go, that feels like a weird answer. So I was going to put it in here. And then do you know what would happen? I'd have log base -4. And you can't have negative bases. And so therefore, I knew it was going to be wrong. But I didn't know where I had made my mistake. So thank you for helping me figure that out. So now I'm adding 4 to both sides, and I get 8. And now I'm going to double check it. Put in an 8 there. Log base 8 minus 4 is 4. So that's really saying 4 to the 3/2 equals 8. And is that true? And the square root of 4 is 2. 2 cubed is 8. Yep, it works. So I double checked it even. I'm sure that one works. The only thing that doesn't work for is it won't catch if you forgot a solution. Like if the answer is really 8 and -8, it wouldn't have caught me on that. Like checking it doesn't fix that problem. All right, I don't think we need to do this. The numbers are just getting bigger. It's really not the same. It's not any different. Okay, you'd go 3x plus 1 to the 5th equals 239, and it says with a calculator. That's all. So we'd put both sides to the 1/5 power, and then you'd have 3x plus 1 equals some smaller number than that. I don't know, 13 or whatever. And then you just solve it, and it's a super easy equation. As long as you can do 239 to the 1/5. All right, so let's not waste time on that one. Again, these are good to, they're just really easy. I bet you can probably do this in your head. Look at the first one, in your head. X to the 3rd equals 64. Are you able to do that in your head now? So x to the 3rd is 64. What's x got to be? 4. Because 4 to the 3rd is 64. That makes sense? Okay, let's do the other one and see if we maybe could even do this one in our head. X to the 1/2 equals 5/2. So the square root of something is 5/2. A little harder to do in my head. Maybe I'll write the first step down. (25/4). You got it. What you're really doing is squaring both sides. 25/4. Okay. This one, again, it's just a little more complicated, but it's the same exact concept. I don't think we need to go through anymore. I think you're good. So now, what kind of solving do we focus on today? You had the x's always in the what? In the base. And what kind of we're going to learn next? I'll tell you that part. We're going to go to the kind where x, actually I'll probably do 2 days in one. I'm trying to get you a little ahead, actually, because Pi Day is coming. Pi Day is Saturday, yes. For those of you that want to celebrate alone, it is the best Pi Day. I really wish it was like Friday, but anyway, it's not. So we're either going to do it Friday or Monday. It kind of depends on the schedule for things, but anyway. Okay, only other thought is there's 4 little rules that I sprung on you the other day, and I just want to make sure you get them. Log base 3 of 2 times 5. Do you remember how to split that up into 2 logs? This was called the product rule, because product is a multiply problem. There's 2 things. I'll give you a hint. Log base 3 and log base 3. Remember? Yes, but what did you say to put between them? You are correct. It seems like it should be a multiply because, you know, you're splitting up a multiply, but it's a plus. Okay, how about this one? Same exact thing, except I'm going to just change 2 things. Guess what I'm going to change? The times to a divide, and then what do I do in between them? I'll subtract. Do you get that? if you divide, if you have an argument that has a 2 over a 5 or a divide in it, you can change that into a subtract. It's kind of like you're distributing this log to both parts. It's not distributing, but it's kind of like that. And then the problem is that it's not a divide. You'd expect this to be divided by, but it's not. It's a subtract. Okay, and then there was one more, the power rule, that said log base 3 of 5 to the second. You cannot say that the answer is 2. If these had been the same, the answer would have been 2. But this 2 could go where? Out in front. Okay, I'm going to just keep showing you these each day, and eventually, hopefully, you'll be processing them pretty well. That takes the power from here and moves it down there. Why does that work? It just does. Logs have different rules than regular math. I sometimes think of it as a whole different language. Yes?
I was on my calculator and I noticed that log 10 to the 1 is 0. Is there any?
Log base 10 of 1. Okay, how about this? Would you agree that 1 is the same as 10 to the 0? And therefore, if these two are the same, that's the answer. Okay. Another one was this. If I have log base 3 of x equaling log base 3 of 2x plus 4, then since they have the same log base, x equals 2x plus 4. And you can solve that equation. So if they have the same log base, it's not really canceling them. What it's really doing is saying this equals that. Because it makes sense. If he's going to have log base 3 on the one side and log base 3 on the other, then this must be the same as that. That equals that. Okay, then there were some really quick ones. You remember my dumb saying, if you won the argument, you get nothing. You have a 1 here, doesn't matter what's here. So a tricky way to ask that would be like log base x of 1. Because a lot of people would be like, what? X to the x, how am I supposed to know what to do? You didn't tell me the other number. Well, if this is a 1, it doesn't matter what this is. The answer's got to be 0. If you won the argument, you get 0. Okay? And then there was that other pattern we just talked about where if you go log base 3 of 3 to the 5th, then the answer is what? 5. If these two are the same, the power is the answer. And one other little one that's used, it's more obscure, but if these two are the same, then what do you think? The 2 is the answer. Now, these are just little patterns that happen to always work. They're not how you should learn logs, but once you kind of get how you rewrite the logs, that's the main thing, is can you rewrite logs and exponentials. Then once you got that, you start noticing these patterns. Like, why would I want to have to say equals x and do a rewrite 5 to the x equals that, you know, log base 5 of x is equal to log base 5 of 2, and then since there's that rule about how if these bases are the same, these are the same, and then come up with x equals 2, when you can just notice the pattern and go, oh, they're the same, answer's 2. Okay, so we're just trying to show you those. You actually don't have to know them yet. We're deciding whether or not we're going to even put those on the test, but if we do, I want you to be ready for it. So, okay. And that's all you need to know for today. Your assignment is very, doable, likable assignment.